Hi there, peeps. Um, well, this is my other video where I'm just gonna go through. I'm still going through the Eastern Cape, Northwest, and your Free State past papers. Uh, their trial exams, paper one. But on this video specifically, I'll be looking at probability. Well, from what I know, most students hate this chapter, um, and it only counts like three. Sorry, not 3%. It only counts like 50 plus or minus 15 marks of your final exam, paper one. Um, and this, for me personally, I believe this is the coolest chapter ever, and it's the most easiest chapter where you can get your marks. But this video is not about me, so let me just get straight to the point. I'll start with the Eastern Cape paper. Well, on this question, they were given that events A and B are mutually exclusive. And then they were further given that the probability of A equals to your 0.35, and then your probability of B equals to your 0.52. So, well, first things first, what you need to understand here, or what you need to know, they've given you a very important feature or a very important property by telling you that events A and B are mutually exclusive. So if they tell you that the events are mutually exclusive, I think to you it should make sense that you should remember from your theory that if your events are mutually exclusive, that basically means that your events they've got an intersection of zero. So what happens when you look at your Venn diagram? I'll just quickly go through the theory for you guys. I'm just gonna go quickly through this because this is your revision. I'm not trying to teach you a new concept or something. Sorry. Oh, yeah. If you've got your events A and B, according to this event diagram, your events A and B are inclusive. Why am I saying your events A and B are inclusive? Look at this part. This is basically where your both your events meet. So if this is the part where your events meet, it basically tells you that there is an intersection. So I wouldn't say that these events are mutually exclusive. That would mean that these events, since they have an intersection, that would mean that they are inclusive. All right. I hope we all got that. And then I'm just gonna look at another Venn diagram. I've got event A and my event B. If I've got my event A and my event B on this one, this event is said to be mutually sorry about my they're said to be mutually exclusive. Why are they mutually exclusive? It's because there is no intersection. Remember, there is no intersection. So if there is no intersection, that basically tells us that these two events are mutually exclusive. So remember that in probability, your intersection is represented by the word and, right? So if it's represented by the word and, that should tell you that your and or your intersection equals to zero if your events are mutually exclusive. So each and every time when you see the word mutually exclusive, just think of the intersection equals to zero. Well, let me get to the question because I have to answer what has been asked, not to go through the theory. But I guess that this should help you guys. Well, the question, as stated, the events are mutually exclusive. So immediately you see the word mutually exclusive, just write it down so that you won't forget. Probability of A and B should be equal to your zero. And then they've given you that the probability of A equals to your 0.35 and the probability of B equals to 0.52. And then the first question is looking for the probability of not A. Well, if they say they're looking for the probability of not A, remember that your total probability shouldn't exceed 1. It is always equals to 1. That's your probability scale. Remember that. That means if you suppose that A is the number of students that prefer watching soccer, then to calculate, let's say they asked you to calculate the number of students that do not watch soccer. So from the total number of students in the that you're taking a survey from, you'd say the total of the students minus the number of students that are watching soccer, and then you'll be left with this number of students that do not watch soccer or that do not prefer soccer. So, but on this one, you just, because you're talking about probability, we'll just take the maximum or the total probability, which is 1 minus sorry about that. Oh god, I don't know what I've just done. Sorry about that. But you, from the total probability, you know that your probability scale ends at 1. So you're going to say 1 minus the probability of A. Why am I saying 1 minus probability of A? I'm looking for the number of the people that prefer that do not prefer A. So I'll say 1 minus those that prefer A, and then that would be 1 minus your 0.35, and from your calculator you punch your calculator, since you guys still have the privilege to use your calculators, and then we're left with 0.65. And then you get your 2 marks because this question was basically out of 2. Right, and then the second question was asking us to find the probability of A and B. I just told you from the beginning that these two events are mutually exclusive, therefore your probability of A and B will be equal to 0, and then you get just a simple 1. Question number 3 is looking for the probability of A or B. Well, I'll also need to go through some theory here. If they talk about the probability of A or B, the word or in probability represents the union. I usually make an example of the teachers union. Just think of a teacher from the Western Cape, just think of a teacher from KZN, a teacher from Gauteng. All those teachers, when you need to find the number of teachers from SADTU, sorry to call out the what's this union's name, but I'm just trying to make an example. If you take one union like SADTU, when you need to calculate the number of teachers that are under SADTU, you'll take the number of teachers from Western Cape, the number of teachers from Gauteng, and the number of teachers from KZN, and then you'll come up with the union. So, but on probability, we have this thing that we call the probability sum, which it's a formula. Basically, it's provided on a formula sheet which says probability of A or B will be the probability of A plus the probability of B minus the probability of A and your B. So this just makes sense. It doesn't even need you guys to know probability or something. So because basically what this says is that in order to find the union, or in order to find the total number of people, you just say the number of people that prefer A and then the number of people that prefer B, and then you subtract the number of people that prefer A and B in order to have the actual number. Because if you include the number of people that prefer A and B to find the total number, that means there'll be a repetition of a certain number of people. So it's basically easier to say the number of people that prefer A, and then plus the number of people that prefer B minus those that prefer both A and B, so that you'll exclude the part where you repeat a certain number of people, and then you'll end up your probability of A you given, it's 0.35 plus your probability of B is given as 0.52, and the probability of A and B is 0, and then use your calculator to punch this, and then you'll end up with 0.87, and that's where you get your 2 marks. So yeah, that's basically the first question from the Eastern Cape. Make sure that you tune into the next video, or you check out the next video, which will have more of the Eastern Cape question, because this is basically the first part. There's also counting principle, and I'll also go through the Northwest question, and then I'll give you guys a few questions to go through in order to help you out to practice for your final exam. So yeah, just keep checking.